Hello everyone, Rico once again and welcome back to another episode of Mathflex. So to start, let me just say thank you to all those who send us well wishes and heartwarming messages. I really appreciate them all. But nothing to worry now, I am well recuperated and coping with this new normal setup. You know, it's just so fulfilling to realize that what we had started is somehow creating an impact to some of our viewers. You know, after showing the third episode, COVID and I, so apart from the comments we get from the Facebook and from the YouTube, we also receive private messages from our viewers thanking us for the inspiration and also thanking us for somehow easing their pain after watching the video. This platform offers endless possibilities and opportunities. Now that we have this channel, we have greater and wider reach. We can reach as many people as we can. But nevertheless, wherever this channel or initiative will lead us, I will still stand and continue with my advocacies. That is number one, to share whatever God has given me. And the second one is to be more socially relevant. And lastly, to continue fostering this family deserving a better life. Special shout out to our big boss Jun Bautista for sponsoring this shirt. I think this is one of those affirmations we get from our viewers, from our friends, from our subscribers, that what we are doing is on the right track. So it inspires us more to do better. So again, to our big boss, Jun Bautista, thank you very much. So let's try this. Let's go directly to our board work. So our topic for today is all about geometric progression. So if you would recall, the second episode was all about arithmetic progression. So the other half of that is actually geometric progression. So what is geometric progression? If you would recall also the definition of arithmetic progression, so a series of number is said to be in arithmetic progression if the succeeding terms have common difference. So for geometric progression, a series of number is said to be in geometric series or geometric progression if the succeeding terms have common ratio. So what do we mean by that? So let's have this example of geometric progression. So we have 2, 4, 8, 16, and 32. So as defined before, that geometric progression, succeeding terms have common ratio. What do we mean by that? So if you try to divide 4 divided by 2, you'll have a ratio of 2:1 or 2. Also for 8 and 4, so if you'll divide 8 divided by 4, you'll get 2 also. Same rule with 16 and 8 and 32 and 16. So this series is said to be in geometric progression. So just like in arithmetic progression, each term or each number in the series, we call them as term. So in this case, 2 here will be our first term, 4 here will be our second term, third, fourth, fifth term. This series satisfies the definition of geometric progression because succeeding terms have common ratio of R. If I would like to get now the second term of this geometric progression in terms of the first term, so we can write a formula or an equation, something like A2 is equal now to A1 times the common ratio of R, right? Also, if I want also A3 in terms of A1, so I'll have it like A3 is equal to A1 times R and another R there, so it's R squared. And then A4 also will have A1 R cubed, and also the last one would be A1 r to the fourth. Also, if you want to express this formula in terms of the number of terms, you can have a2, which is also equal to a1 r raised to 2 minus 1, right? 2 because it's the second term. Also here, a1 r 3 minus 1. And also for the other terms, a1 r4 minus 1. And the last term or the fifth term is a1 r raised to 5 minus 1. So in other words, if you would see the pattern here, that we can derive a conclusion to get the nth term of a geometric progression, we can have a general equation of an, okay, is equal to the first term times the common ratio raised to the number of terms minus 1. So this is now our general formula for finding the nth term of a geometric progression. So problem involving geometric progression, so sometimes we are asked to find the sum of all terms in a series. So let's try now to derive the formula on finding the sum of all the terms in a series of geometric progression. So if I have these terms, so the first term up to the fifth term, so we'll try to get now the sum of all these terms, right? Now, I have to make another equation in such a way that I can eliminate some of the terms and will have a more manageable equations in terms of the sum of all the terms. So if I will multiply the first equation by r, okay, a common ratio of r, so we can have a second equation like r Sn is equal now to a1 times r is a1r, then a1r squared, then a1r cubed, okay, a1r to the fourth, and a1r to the fifth. So we have now our second equation. Next, what I will do now to the first equation and the second equation so that I could eliminate some of the terms. Again, let's try to have a review of our basic algebra. So if I have x plus y is equal to 3 and x plus 3y is equal to 5. So to eliminate x, so I have to subtract the first equation to the second equation, right? So I'll have an equation involving y only. So same through here. So if you want to eliminate some of the terms which are actually the same, so you have to now to deduct the second equation from the first equation. So this is our first equation and this is our second equation. So let's try that one. So Sn now is equal, or sorry, Sn minus r Sn is equal now to a1 does not have any term similar to the second equation, so a1 there. So a1 r1 is the same as this one, so this cancel out, this cancel, and cancel. So what's left now is a raised to a1 raised to 5, right? So a1 raised to 5. So this is negative because we are subtracting this from the first equation. Technically here, r raised to 5 or the 5 here is the total number of terms, so we can express this one in terms of n also. So you have Sn minus r times Sn is equal now to a1 minus a1 r raised to n. So if factoring out Sn there, so you have Sn 1 minus r, and factor out a1 here, so a1 times the quantity 1 minus r raised to n. So solving for n, solving for Sn, so Sn then is equal now to a1 1 minus r raised to n divided by, okay, this one, which is 1 minus r. So which gives us the equation on finding the sum of all terms in a geometric progression. So let's have this first problem on geometric progression. So we are asked to find the 10th term of geometric progression 3, 9, 27. So now, what are the given values? So we have the first term, which is 3, so we can have a1 is equal to 3. And then the other given, which can be derived from the given series, is the common ratio. So what's the common ratio? So 9 divided by 3 is 3. And 27 divided by 9 is 3. So the common ratio here, okay, R is equal to 3. Then we are asked to find what is the 10th term of this geometric series. So as we derived before, the formula for getting the nth term of a geometric progression or geometric series, we have an is equal now to a1 r raised to n minus 1. So substituting the value here, so you have the 10th term is equal now to the first term times the common ratio times the number of terms, which is 10. The common ratio raised to the number of terms minus 1, so 10 minus 1. So a10 then is equal now to, so you have a value which is 59,049. So in other words, this is the 10th term of this geometric progression 3, 9, 27. So in this case, we have letter C as our answer. By just analyzing or looking at the choices, I think you can actually eliminate 2 of them. So these are the choices. So what do I mean by that? Since the first term is 3 and the common ratio is an odd number also, which is 3, so an odd number raised to any number will always be an odd number. So in this case, those choices that are even number are not actually or will not give you the right answer. Okay? So let's go to our next problem. So let's try this second problem. So it says that if the first term is 2 and the last term is 2048, find the number of terms if the common ratio is 2. I think everything is given, so we just have to identify them. So first, it says the first term is 2, so that is our first term, a1, and then the last term, so an, since we don't know the number of terms, so an is 2048, and common ratio of 2, r is equal to 2, then we are asked to find the value of n. So let's try to write our formula. So a1 is equal now, an is equal now to a1 r raised to n minus 1. So we just have to plug in the values. So what is the an? So it's 2048 is equal to 2 times a common ratio of 2, and the number of terms we don't know, minus 1. So 2048 divided by 2, that's 1024, is equal now to 2 raised to n minus 1. So how do we get the value of n here? So taking the logarithms of both sides, so log 1024 is equal now to log 2 raised to n minus 1. So in this case, okay, so the n minus 1 here, since it's exponent, so rule of logarithm, so you can put it here, so we can rewrite it as log 1024 is equal now to n minus 1 times log 2. So n minus 1 then is equal now to log 1024 divided by log 2. So in this case, you'll be needing calculator. So log 1024 divided by log 2. So this is n minus 1 is equal to 10. Okay, this value is 10. So therefore, n is equal to 10 plus 1, which is 11. So in this case, our answer is letter D. Okay. So another way to solve it is by substituting the given choices. So whichever will give you an answer, by plugging in the given here, whichever they give you the answer which is equal to 2048, so that is the right answer. In case only that you forget or you don't know how to solve it by logarithm, so you can do that also by substituting the choices in the given formula. So let's go to our next problem. So our next problem is we are asked to find the sum of the first 6 terms of this geometric progression, 1, 1/2, and 1/4. So let's try to identify the given. So 1 here will be our first term, okay? And then since we are given already the first 3 terms, so we can derive the common ratio. So what will be the common ratio? 1/2 divided by 1 is 1/2. 1/4 divided by 1/2 is also 1/2. So therefore, our common ratio is 1/2. And then we are asked to find the sum of the first 6 terms. So writing the formula, sum of all the terms, okay, Sn is equal now to A1, 1 minus r raised to n over 1 minus r. So it seems like everything is given, so we just have to plug in the values. So Sn then is equal to 1 times 1 minus r, so a common ratio of 1/2, okay, raised to, okay, n, so 6 terms, divided by 1 minus 1/2. So therefore, you'll have a sum of, okay, so what is 1/2 raised to 6? So 2, 4, 8, 16, 32, 64, right? So 1 minus 1 over 64 divided by 1 minus 1/2 is 1/2. So 1 minus 1 over 64, so if this is 64 over 64, so that means that is Sn is equal now to 63 over 64 divided by 1/2. So therefore, this will come there. The 2 will be up, so 126 divided by 64. So reducing to the lowest term. So our 6th term, or the 6th term, sorry, since we are asked for the 6th term, is equal now to 63 over 32. So our answer here is letter A. Okay? So again, no, if you're taking any exam, especially on math, so some of the choices are obviously not the answer. So in this case, which choices do we think that are not the possible answers? Okay, so we are given, we are asked to find the sum. So that means 1 plus 0.5 plus 0.25. So definitely the answer will be more than 1.75. So 63 over 64 is less than 1. And 3/2 is only 1.5. So which is less than also with 1.75. So definitely B and C are not the answer. Our last problem, it says find the sum of the infinite geometric progression 1, negative 1, 5, and 1 over 25, and so on. So what does it mean by infinite geometric progression? So that means that if you will extend this one infinitely, we have to find the sum of this series. So It sounds not possible, but it's possible. So how we can get that? So let's try to work on the formula first. So again, the sum of all terms in a geometric progression, so we say that Sn is equal now to A1, 1 minus r raised to n, okay, over 1 minus r. So by inspection here, you will get an r value which is negative 1,5 divided by 1, that's negative 1 over 5. 1 over 25 divided by negative 1 over 5. You'll get also a value of r which is negative 1 over 5, right? So this is our r value. So if I have an r value which is greater than negative 1, okay, but less than 1, okay, so, and then this, if this would be raised infinitely, that means n here is infinity, or a big number. So you'll find that a smaller number raised to a bigger number, or a decimal number raised to a bigger number, this quantity is approaching 0. So in other words, we can simplify the formula for finding the infinite geometric progression as Sn is equal now to A1, okay, times 1 minus 0, so that's times 1 over 1 minus r. So this is now our general formula for finding the sum of the infinite series in a geometric progression. So to answer this problem, so let's try to plug in. So Sn now, okay, so sum of the infinite series is equal now to A1, which is 1, minus 1 minus, the common ratio is negative 1 over 5. So therefore, Sn is equal to 1 over 1. Negative times negative is positive, so 1 over 5. That's 1 over 5, so that is 5 over 5 plus 1 over 5. So Sn then is equal to 1 over 6 over 5. So the 5 comes up, so therefore the sum of this infinite series geometric progression is 5 over 6. Okay? So this is now our answer. So that's it for today's episode. So I'll be leaving again another problem for you to solve, and I want you to comment down below if you get the right answer, or if you get an answer for this problem. So again, thank you very much, and don't forget to like, watch of course, subscribe, and click the notification bell for you to be updated on our succeeding videos. Till next time, bye-bye!